It's higher, so we see an increasing temperature over time that sort of parallels the carbon dioxide concentration. We also know that emissions are expected, of these greenhouse gases, are expected to remain elevated and increase even more throughout the remainder of the century. And so scientists project that global temperatures are projected to increase another 2 to about 11.5 degrees Fahrenheit worldwide by the end of the century. In the United States, temperatures are likely to increase by even more, and that will vary from place to place depending on where you are. It could be a little bit less, it could be a little bit more, but the bottom line is temperature increases are expected across the board. Well, that's looking at the global and the United States, but what about where we live here in the Southeast? We can focus in a little bit further, and we can see that in the last 40 years, temperature in the Southeast has risen 2 degrees Fahrenheit. In terms of precipitation, we've actually had larger areas of moderate to severe droughts. We've had an increase of about 12% during the springtime and 14% during the summertime, so that's a pretty substantial increase in drought area over these last few years. In the future, it's projected that the annual average temperature in the Southeast as a whole is expected to increase anywhere from 4 to 10 degrees Fahrenheit by the end of the century. What kind of impact does that mean for us here in the Southeast? Scientists have done a lot of research, and they are projecting that we are going to experience more heat waves more often, and these heat waves are going to be more intense and last for longer periods of time. It's possible that we will have more drought, although there's no definite consensus on that, especially when you go to localized regions like us here in western North Carolina. We don't have those projections. The average summer heat index is expected to increase 8 to 15 degrees Fahrenheit by the end of the century. So with the heat index increasing, the heat waves, that leads to a lot of air stagnation, pollutants can build up, and you're looking at significant adverse impacts on human health and the environment over this next century. One of the other things that we're expected to have is increases in heavy downpours. As temperatures warm in the atmosphere, you have more evaporation from the ground, and it goes into the atmosphere. A warmer atmosphere can actually hold more water vapor. So it collects the water vapor, and then you have these, heavy downpours. So it will end up that we'll have fewer precipitation events, but when we do, they may be more extreme. And of course, that can lead to flooding and runoff problems. That's the effect of these long-lived greenhouse gases on our planet and on us here in the Southeast. But what are the effects of the short-term gases and particles? They have more regional and local effects. Depending on what kind of gas or particle it is, it can create a warming or cooling effect. So, for example, tropospheric ozone and soot both absorb sunlight, and so they are going to create a warming effect in the atmosphere, so that will enhance the global warming effect that we're feeling. On the other hand, nitrates and sulfates, dust and organic carbon all reflect sunlight, so they actually create a cooling effect and mask the global changes that we're seeing. And looking at what short-lived gases and particles affect us here in western North Carolina, there's 3 pretty major sources. One of those is coal-fired power plants, both in North Carolina and in surrounding states. And some of their major emitters are soot, sulfur dioxide, oxides of nitrogen, which we refer to as NOx, and volatile organic compounds, which we call VOCs. Vehicles also emit NOx and VOCs, and trees themselves, I don't know if I would call it a pollutant, but they emit naturally a lot of VOCs in the atmosphere, and as temperature increases, there's actually an exponential increase in the emissions of their VOCs. Soot is a particle and it creates a warming effect, as we discussed. Sulfur dioxide in the atmosphere is converted through photochemical processes into sulfate particle, which creates the cooling effect on the environment. And NOx and VOCs in the presence of sunlight react to form ozone. Ozone is actually a greenhouse gas, and it too creates a warming effect on the environment. So what does all this mean for us here in Western North Carolina when we're looking at the context of the global warming and the effects of the short-term gases and particles on our region? Basically, projected warmer temperatures and heat waves combined with area traffic and other pollution sources could lead to higher levels of ozone in the area. A study done by NASA a few years ago suggested that there will be a 3 to 5% increase in daily maximum ozone concentrations for every 1.8 degree Fahrenheit temperature increase. So if we're projected to have an increase of up to 10 degrees Fahrenheit, that can be a 25% increase in ozone concentration simply based on the temperature increase and nothing to do with extra emissions. Emissions from coal-fired power plants can be transported by winds into our region. Ozone and other oxidants can, ozone is an oxidant and it has an effect on how quickly particles are formed. So it can actually increase how quickly gases become particles. And the bottom line is that these high levels of ozone and particles create numerous adverse effects. They cause respiratory and other health problems in humans. They can harm plants and animals in the environment, and they can reduce visibility on the local and regional level, which certainly can have a very large impact on the tourism industry here in Western North Carolina. And so with that, I will turn it over to the next speaker. The doom and gloom.
That's true. You have to know this now. Okay, it's going to be one of those days. Paul?
Well, that's a great setup. Thank you very much. So now we're getting to Western North Carolina, and I'm going to talk about ozone and fine particles. She talked a little bit about the formation of those. Ozone is not something that's emitted directly by industry or cars or anything in the atmosphere. It's formed with reactions of NOx and VOCs. And fine particles, a lot of ours are sulfates. She mentioned that's SO2 gases from burning coal primarily. And the way we look at the health impacts, because our National Ambient Air Quality Standards are set to protect human health. That's what we work with. That's the purpose of them. And they're set up according to an air quality index that EPA uses. And green's good, yellow's moderate, orange is where you start getting into problems, especially for sensitive groups. If it's red, it's unhealthy for everybody, and God help us if we hit purple. So I'm going to start off talking about ozone. What EPA does is they periodically tighten up the standard, make it more stringent. And that happened this year for ozone. We're in our first year with the new ozone standard. And that standard is 75 parts per billion, if I can hit it right here, is the standard. So that's where the end of the yellow moderate range ends. It's supposed to be okay up through